I'm Mark Sponsler, and welcome to the Stormsurf Video Surf forecast for the week starting Sunday, August 14th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and smash the like and subscribe button. You'll get automatic notifications when we post the video, typically on Sunday evenings. Alright, let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a gale developing southeast of New Zealand with 31-foot seas aimed off to the northeast. This should produce some small swell that will eventually radiate into Hawaii about a week out, into the U.S. West Coast, maybe about 9 days later. Other than that, a gale fading off of Chile and producing swell aimed mainly at South America, but of no interest to the U.S. West Coast. All right, let's get into the details. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a push into the jet to the north, just like right here. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure, and low pressure, of course, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area, get groomed out, eventually turn into swell, and of course, swell, when it hits your beach, turns into surf. So we have a decent trough in the South Pacific, but we need to be mindful of the fact that the ice line is pretty much at its seasonal north extent. It's the dead of winter down south, and the ice line right about 62 south, so something like that. So wherever there's ice, wind can't get traction on the ocean surface and does nothing for swell generation. So the area really of interest is just this little spot right in here. But at least the winds are 140 knots, pushing to the north, offering some potential. And that is forecast to continue into Monday, August 15th. And then that gale pretty much starts fading, gets pinched off, but not to be completely outdone. Another trough is forecast developing over the central South Pacific on Wednesday evening, August 17th, building into the 18th with 120, 130 knot winds aimed well off to the north, offering good potential for gale formation, even continuing into Friday, August 19th in the southeast Pacific before pinching off and fading out. And now it even looks like potentially a second tertiary trough might form behind that on Sunday, August 21st, almost a week out, but getting pretty weak. Not sure that anything will come from that. Behind that, a big ridge building south down into Antarctica does the exact opposite of a trough. It creates high pressure aloft, and that does nothing to support gale formation. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, New Zealand again, South America here. Big gale down pretty much over the ice line with 45 knot winds. This is the gale we're interested in, 35 to 40 knot winds aimed off to the northeast, getting traction on the ocean surface, generating 31-foot seas, and then pushing off to the northeast a little bit as we get into Monday and starting to fade. A little bit of secondary fetch there, 35 knot winds, but really we're not expecting anything from it. Strong high pressure, 1040 millibar high develops east of New Zealand as we get into early Wednesday, but we know another trough is forecast here in the central South Pacific on Wednesday evening. That'd be the 17th, with 40 knot winds north of the ice line, building in a broader area at 40 knots as we get into Thursday the 18th, and continuing into Friday with a little patch of 45 knot winds aimed well to the north, getting good traction, certainly, and then even continuing perhaps into Saturday, then fading out. Some secondary fetch, now modeled, this is the 18Z run of the model, just showed up, little tiny area of 45 knot winds, possibly producing yet more swell. We'll see what really happens. Never trust a model a week out. Now we're going to take a look at the effect of the winds on the ocean surface, but we're going back a week. Just a quick review. And so we're on Sunday, August 8th, looking. Small gale here has developed, or did develop, but all of its energy was aimed off to the east. No expectation that swell will result. Another tiny fetch developed, but way down south. Again, all aimed off to the east. Nothing really expected from that. Yet another gale developed on Friday, August 12th, producing a tiny area. Let's go back right here. 30-foot seas on the very hairy edge of the Southern California swell window. Dana Point, something like that's right around 117, 118 west, so right there. So maybe a little bit of energy radiating off to the north from that, but I think the operative word here is going to be small swell. Now that gale developed pretty well once it got east of the California swell window. Certainly energy is expected for Peru and Chile and South America, even up into Central America, but probably nothing for the U.S. West Coast other than what we just talked about. And then here we go, moving into Sunday, we'll say even Saturday night, the gale started developing south of New Zealand, 32-foot seas, down to about 30 feet on Sunday morning. This is the highest seas over the whole domain, but these are the highest seas over here, well out of the California swell window. And that is all we have for the Hindcast. Let's go look at the forecast. And now, forecast. Looking at what's going to happen with this gale. Not a whole lot, really. 30-foot seas, probably more swell for Hawaii than U.S. West Coast, just given the closer proximity and the shorter travel distance up to the Hawaiian Islands, but maybe some rideable swell. Not a whole lot more. As we get into Monday and Tuesday, things settle down. We know another gale's coming. There it is. 30-foot seas developing on Thursday morning. Now, this is a significant downgrade from even a day or two, where at one point I think there were 45-foot seas forecast from this thing. Now it's down to maybe 28 or 29-foot seas, trying to redevelop a little bit on Friday. So maybe background swell or rideable swell. I mean, the fetch area is pretty decent size. I mean, we're just eyeballing here. We haven't run the numbers, but something rideable. And then we look beyond that, and really not a whole lot else forecast. Next up, wind swell production. Also notice, before we get into that, low pressure in the Gulf of Alaska. Typically, on a really good year, you can actually get a tropical system that recurves off of Japan, ends up in the Gulf of Alaska as early as August 15. We've had rideable surf in Northern California as early as that date. Nothing large, but it was rideable and it was noticeable, and the gale itself was somewhere in the western Gulf of Alaska. So this is not unusual to see something. We're not expecting a whole lot this year. Anyway, Sunday, here we are. Winds 15-20 knots along the California coast, making for some junky short-period wind swell. Light trades for the Hawaiian Islands. We get into Monday, pretty much more of the same. Oh, that's right. San Francisco here, Point Conception here, Southern California down here. So this fetch, this area right here along Cape Mendocino, typically in the summer you get high pressure. The Gulf of Alaska creates a pressure gradient along the coast here, makes for 20, 25, even 30-knot winds, and you get wind swell down along the coast. Better than nothing if there's no southern hemiswell, though the preference is big, long-period southern hemiswell. So you get in Tuesday, more wind swell, some more low pressure in the Gulf of Alaska. Wednesday, the 17th of August, again, maybe a little bit of wind swell, but a relatively lighter wind regime along the California coast. No real trades and no real trade wind swell for the Hawaiian Islands. Thursday, pretty much the same sort of deal. Now you can see low pressure off here. Some of the models have actually suggested even up to 20-foot seas from this low pressure system. We're not holding our breath on that. All smells like a bunch of hype this early. There you go. You can see it. 35-knot winds forecast in this gale. We'll believe it when it happens. It's a La Nina year. It seems kind of unrealistic. Anyway, Friday, 20 to 25-knot north winds along Cape Mendocino. Good for some short-period wind swell. Trades pick up to 15 knots for the Hawaiian Islands. And then everything fades out along California and for the Hawaiian Islands. And the gale up here continues circulating, only it's a low-pressure system now as we get into Sunday, and even that fading. Light wind regime for California, Hawaii. So the net effect is, from a wind swell perspective, a little bit of wind swell during the week for California. Nothing really for Hawaii. Maybe eyes on a little bit of a low-pressure system up here in the Gulf of Alaska, but we doubt any meaningful swell will result, even if that forms as forecast. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? So the first half of this discussion, we're going to talk about the Madden Julian Oscillation, a periodic weather oscillation, two phases, active and inactive. The active phase is on one side of the planet, the inactive phase on the other. They rotate opposite of each other around the planet from west to east on the equator. The active phase is effectively a low pressure system, a pool of low pressure system. It imparts energy up into the jet stream, helps feed the storm track, and also when it moves over the West Pacific in what's known as the Kelvin wave generation area, it helps reduce or eliminate or reverse trade winds in that area, which can take warm water that's typically in the West Pacific, start shoving it east under the equator. Eventually, that warm water takes about 3 months to make its way across the Pacific, will erupt off of Ecuador. If you have successive active phases of the MJO and successive Kelvin waves, they start building up a pool of warm water off of Ecuador, and that can be the start of El Nino. La Nina does the exact opposite. The inactive phase of the MJO does the exact opposite. It steals energy from the jet stream and suppresses storm development and creates sort of the opposite of a Kelvin wave, a cool upwelling event along Ecuador. All right, so we're looking for signs of the active phase of the MJO. This is data from the TAO buoy array. Series of buoys strung across the equator used for monitoring El Nino, but the wind indicators on that are good for monitoring the MJO. This is the East Pacific here. This is the West Pacific here. We're just looking at the arrows. The arrows, the longer the arrow, the stronger the winds, and the direction pretty self-evident. So strong east winds in the East Pacific, strong east winds in the Central Pacific, and moderate east winds. That is New Guinea there. That is the equator there. That is the international date line right there. The Kelvin wave generation area is this area roughly just from about the date line, 5 degrees north and south of the equator over the West Pacific, and winds moderately strong out of the east. But it's not the actual wind speeds, it's the difference from normal for this time of the year. Sometimes the winds normally blow pretty strong, and the ocean is very sensitive to just those changes. So in the East Pacific, right now, yeah, winds are strong, but not really any stronger than normal, just a hair bit, one little arrow out of the east, so just about normal. In the Central Pacific, maybe winds are a little bit stronger out of the east, but in the all-important Kelvin wave generation area, yeah, winds are modestly stronger from the east, probably indicative of the inactive phase of the MJO. If these arrows were reversed in direction, that could potentially be the active phase of the MJO, but we don't see that at the moment. So what's the wind forecast for the Kelvin wave generation area for the next week? All right, this is zonal wind anomalies, just fancy words for are the winds blowing stronger out of the east or stronger out of the west. The purples, blues, those are stronger easterly winds. One can look at that as the inactive phase of the MJO, but if it's set up for months at a time, like kind of what we're seeing here, that's probably a sign of La Nina. The reds and yellows, the active phase of the MJO, westerly anomalies, those that are good for creating Kelvin waves. We don't see any of that or much of it. What we see here right now, in fact, let's get ourselves oriented. Well, the date line runs right up the middle of the chart. This is the whole planet on one chart. We just need to figure out what's going on in the West Pacific, because that's where all the magic from the MJO happens. West Pacific starts about 135 east, so right there. This is the forecast right here. So from here to about 170 west, that little box right there. And that's just the next week's forecast. All we see is blues, easterly anomalies. One can pretty safely assume that's the inactive phase of the MJO, offering no good support for storm development or no excessive energy transfer to the jet stream. Now, we looked at the chart, there are gales happening in the South Pacific. So the inactive phase in this sort of pattern doesn't preclude gales from forming, but if you saw these oranges and yellows right in here, then you would know there's increased chances or enhanced opportunity for gale development, or the gales that typically would form would be supercharged by these westerly anomalies. But we don't see any of that. If anything, we see the MJO stealing energy, destructively interfering with the typical MJO flow. So let's go out 2 weeks. Let's take a look at outgoing long wave radiation. All right, you sort of hunt and pick and find the models you can to best describe the MJO. All right, the MJO, the active phase, because it's a low pressure system, generates clouds. Clouds inhibit the reflectivity of sunlight off the ocean surface, and that's what this model's about, outgoing long-wave radiation. Now, the yellows are actually enhanced reflection off the ocean surface, so one can assume that's the inactive phase of the MJO, because the inactive phase is a high-pressure system. High pressure is typically cloud-free skies. Let's get ourselves oriented here. South America, Central America, Hawaii, New Guinea, Australia, the equator right there, dateline right there, Kelvin wave generation area right in here. That's the important area. So one can say the inactive phase of the MJO, a very weak one, in control today. 5 days from now, you can see right there, same deal. 10 days from now, same deal. And 15 days from now, roughly 2 weeks from now, maybe the inactive phase, a little bit more defined, but in all, almost a neutral pattern, turning weakly inactive, this per the statistic model. Now, the dynamic model here suggests, well, the inactive phase getting a little bit stronger on days 10 and 15. So one can assume we're kind of in a neutral phase, moving towards the inactive phase, the MJO, a less favorable environment for storm production. Drilling into that just a little bit deeper, we have phase diagram charts, another way of depicting the MJO. Right? The MJO moves from west to east, from the Indian Ocean to the maritime continent. That's like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Round and round it goes. Both the active phase, so if the active phase is here, the inactive phase would be over here. So where is the heavy dot at? Right here. This is where the active phase is right now. So in the Indian Ocean. So one can assume, generally speaking, the inactive phase is over here in the West Pacific. Right, and this is the forecast track, 1, 2, 3, something like that. So basically, the statistic model suggests the inactive phase just noodling around in the Indian Ocean. And if the heavy dot is inside this circle, it's considered to be exceedingly weak. You really want to see this dot in the West Pacific way up here somewhere, then you'd be in for massive energy transfer to the jet stream and massive storm development. We don't see any of that at the moment. Now, the dynamic model paints a similar but different picture, same starting point, inactive phase weak in the Indian Ocean, sort of noodling around for about the next week, and then making it a little bit further east to, we'll say, the East Indian Ocean, and still pretty weak, modest at best, and still not really anywhere to help us. We need this dot in the West Pacific somewhere, and we're not there. Next up, the upper level model showing areas favorable for precipitation. The greens favorable for precipitations, the orange and yellows not favorable. Let's get ourselves oriented. This goes out 40 days, by the way. 5 days on each panel, 8 different panels. South America, Central America, 0 is the equator. Dateline roughly there, New Guinea there, Philippines there. Kelvin wave generation area right in here somewhere. All right, so this suggests, and if the greens are favorable for precipitation, and we said the active phase of the MJO is like a low pressure system, one can assume the greens are the active phase and the yellow and the oranges the inactive phase. So you can see the actual oranges moving over the Atlantic, inactive phase. That would inhibit tropical storm development there. There's been some discussion, and we're not going down that rabbit hole tonight, but this is supposed to be a strong hurricane season for the Atlantic, and as of right now, there's not been a whole lot going on. And with the inactive phase pushing over the Atlantic during the month of August, you can see the dates here, probably that forecast is overhyped. Anyway, active phase today, trying to move into the West Pacific, making its way across the Pacific and into the East Pacific by the first week in August, and then fading from there, with the inactive phase behind that building, we'll say, the first week of September, and building and taking over beyond that. So let's go take a look at the CFS model. This goes out 1 month, the forecast down here, past performance up here. This is the whole planet on one chart. This is the east-west component of the wind again. The blues, easterly anomalies, the inactive phase roughly. The reds and yellows, or reds and oranges, the westerly anomalies, the active phase, the MJO. Dateline runs right up the middle. The Kelvin wave generation area, far West Pacific, starts about 135 east, so we're interested in this area right in here. And according to this, what we see, so this solid contour here, that's the active phase of the MJO, and you can see it, a little piece of it here. If you kind of extrapolate, you could say, well, this is the active phase of the MJO here, making its way across the Kelvin wave generation area through the end of August, which is pretty much what we saw on the other model. A couple little patches of westerly anomalies, but not the active phase not really getting any traction. It's being destructively interfered with by this high pressure bias, this purple line here. That is the La Nina signature, and we won't go too far down that rabbit hole either. But then the inactive phase comes behind that, the dotted contour, pushing across the Kelvin wave generation area as we get into the end of August into early September. You can see light easterly anomalies with pockets, the reds and yellows, yellows or oranges, of westerly anomalies for the next week to week and a half, something like that. Then the inactive phase takes over, and the blues start showing up, stronger easterly anomalies building as we get into the early part of September. That's typically when we would want to start looking into the North Pacific for storm development. We don't think that's going to happen. There will not be an early start to this fall, and honestly, that's pretty typical of La Nina. It seems like during La Nina years, especially when it's dug in, the fall season is delayed by 4 or even 5 weeks, something like that. And winter, the same sort of deal, a delayed start. And then finally, the CFS model going out 3 months. Past performance is down here. The forecast is at the top. The date line runs right up the middle. Kelvin wave generation area starts about 135 east, so right in here is what we're interested in. You see this model has been continuing to hype this sort of situation. The blues are easterly anomalies. This is 850 millibar zonal wind anomalies, up about 4,700 feet. The blues, easterly anomalies. The reds and yellows, westerly anomalies. The westerly anomalies are the active phase of the MJO, if not El Nino, if it were sustained and long enough. What you kind of see, you see yellows over the maritime continent. That is where the El Nino component of El Nino has been for the past 2 years. We see blues, easterly anomalies. That's the La Nina component right over the date line. You see the date line right there. And forecast continuing. But notice this, and the model has continued to hype this westerly anomaly pattern building deeper and deeper into the Pacific, filling the Kelvin wave generation area, or nearly so, by the end of the model run as we get into late October and November. So let's overlay the MJO here. We'll get ourselves oriented. So right now, here, the solid contour, active phase of the MJO. Again, the West Pacific starts right about here, so it's about halfway through, pushing through the Pacific, through, we'll say, the end of August, maybe not even that long, with pockets of westerly anomalies and reduced easterly anomalies. The dotted contour, the inactive phase of the MJO, setting up the end of August into about mid-September, something like that. Strong easterly anomalies take over the date line, certainly pretty darn strong as we get into the mid to later part of September. And we think that, at least according to this model, will be the final blow of La Nina. After that, the active phase of the MJO sets up, dragging westerly anomalies to filling 2/3 of the Kelvin wave generation area, and then completely filling it as we get into the latter part of October. Maybe another little pocket here of easterly anomalies. But it seems like there is a trend, a mode change setting up where La Nina is just going to sort of lose its top. Let's overlay the low-pass filter here. Now, this is what's even weirder, though. In fact, we'll take the MJO out of here. All right, the dotted contour is the high-pressure bias, the La Nina indicator. The solid contour is the low-pressure bias, the El Nino indicator. According to this model, the El Nino indicator, the low-pressure bias, remains pretty much locked over the maritime continent for the foreseeable future, though you see this line, it sort of is backtracking. It's been backtracking since June, and it's going to reach its peak about the end of September, and then maybe starting to turn off to the east, while the high-pressure bias supposedly, maybe, starts giving way a little bit, this is the real teller. NOAA's been suggesting maybe a three-peat of La Nina this winter, at least into the fall. Certainly that is the case. But beyond there, we sense with these westerly anomalies building, it's not just this model, there's other models. The full rundown on that will happen next week. The IRI consensus, CPC IRI consensus model, which is an accumulation of 20 or 30 other MJO models, all are suggesting the demise of La Nina as we get into the deep into fall and the early part of winter. So we'll see. The real key is this active phase of the MJO, the resulting westerly anomalies. Do they build to the dateline and or beyond? And is that enough to kill La Nina? We'll just have to wait and see. All right, so we talked about the active phase in the MJO and Kelvin waves. Well, let's see if we can see some evidence of Kelvin waves, or let's just examine the balance of warm water and cold water in the subsurface Pacific, down under the surface. Okay, Kelvin waves do not traverse the Pacific on the surface, they go underneath it. All right, so this is the West Pacific here, this is the East Pacific here. And you can see these little X's get down here. These are anchor lines on the TAO buoy arrays. The X's are actual sensors on the anchor lines. They go down about 300 meters, let's say 900 feet or so. And they capture subsurface temperature information that's sent up to a central processing facility that's run through a model. And the gaps, notice there isn't that many sensors. It's not like there's big, what is this, from 140 to 155. So it's at like 900 miles between each set of buoys, right? So you have to guess at what's going on in between. But anyway, you can see the 29-degree isotherm here, right about where it was last week, about 170 east. 28-degree isotherm at 180 west, that's the dateline. The 26-degree isotherm falling back a little bit at 146. I think it was at 140 west last week. And even more, a little bit concerning, is the 24-degree isotherm here. It was the whole way across into Ecuador last week. It is backtracked to 120 west. Just looking at this, one can assume that water temperatures are cooling here in the Eastern Pacific. Now, it's not the actual temperatures, the means, it's the anomalies. The difference from normal for this time of year. In the West Pacific, we see warm water, only 1 degree, that's 1 degree centigrade, not Fahrenheit, so about 1.5 degrees Fahrenheit. Making it to, let's pull this up, to about 55 west, so warm water trying to build a little bit to the west, but we don't think it's a Kelvin wave because there hadn't been any strong active phases of the MJO. Cold water 3 degrees below normal from about 150 west the whole way into Ecuador, and the last of a Kelvin wave fading out here in the far East Pacific. So right now, cold phase emerging, the cold wave of the Kelvin wave cycle. You get warm waves from a Kelvin wave, and then typically you get a cold upwelling right after that. If you're kind of in a neutral thing, if you're in a real deep La Nina, you'll get multiple cold waves in a row. If you're in El Nino, you'll get multiple warm waves with no cold wave in between. Here's another model of the same situation using a little bit different data. Warm water making it to 160 west, something like that, and warmer than what the other model was suggesting, but cold water basically filling the entire East Pacific and even Central Pacific and up to the surface, the last little lingering bits of a previous Kelvin wave all but gone. Sea surface height anomalies. This is not temperatures. This is the height of the sphere of the ocean. Take out the wind waves, take out the waves, take out the tides. Is the sphere of the ocean higher or lower than normal? And over very small areas and very small amounts. All right, South America here, Central America, Hawaii there. That's the dateline. That's the equator there. There's New Guinea there. We have positive anomalies. One can assume that's warm water. Why? Well, warm water at depth expands. It pushes the ocean up above that. Just a little bit, 15 centimeters. In fact, I think we did this last week. We'll do it again. How far is 15 centimeters? It is, that much from there, to about there. So not very much. The sensitive is sensitive enough to be able to pick that up. Likewise, we have minus 15 centimeter anomalies here and here. In fact, we'll scroll up. So that's about at 145 west and about 120 west on the equator. So one can assume there's cold water here. And that's exactly what, in fact, we can go down here. That's what that suggests. And that's what two lobes there at 140 and 120. We think this model is at literally using this data to incorporate in it, where the other model is not using that. It's just literally using the data from the buoys. So you get some slightly different outcomes. Anyway, cold water here, the upwelling phase, no big surprise. Ecuador's there, by the way. So cold water in control for the moment. That is cold water subsurface. Now, upper ocean heat anomalies. This is just the balance of cold and warm water in the ocean, sort of ignoring the surface, all right? Time down here, going back a year, West Pacific here, East Pacific here. Last August, September, November, there was 1, 2, 3 upwelling events. The blue is colder than normal, filling the entire Eastern Pacific, okay? Then we had, in December, January, probably active phase of the MJO, took warm water, created a Kelvin wave, tracked the whole way across the Pacific. Then here was our upwelling phase of the Kelvin wave cycle, again in March, April, and May. Another recent Kelvin wave, didn't even quite make it across the Pacific. And then here is our latest upwelling phase. In fact, see, there was the peak of that one. There's the peak of this one. There's the second little lobe starting to show up. We are hoping that this one here is like this one, a single upwelling event and not a 1, 2, 3. Because if it is a 1 or a 2, then there's no way the models are going to verify, just because, well, it took 1, 2, 3 months for a single cold upwelling event to go through its cycle and be gone. If we're starting in July here, so that's July, August, and September, it would then, as we got into October, that would allow ocean temperatures to start warming, and that would set us up for, by late December and January, to maybe be back into a non-La Nina state, which is what the models are suggesting. We're going to get into that in a minute. But it all hinges on this being the only cold upwelling event and not a triple or even a double like what happened last year at this very same time. Seasonal factors do apply here. It could be that we go back into La Nina, but we're hoping not. The models suggest not. And upper ocean heat anomalies for the area from the dateline to 100 west, so somewhere south of Mexico. That triple, the blues are cold, the oranges warmer than normal. There's that 1, 2, 3 triple dip cold event that happened last summer. Our first Kelvin wave, a miniature cold cycle beyond that. Our current Kelvin wave that just wrapped up in July. Here's the cold cycle we're in now. We're hoping this thing just kind of flattens out here somewhere in the next week or two and then starts working its way up. But if we get another downward spike, then the models are not going to verify. All right, sea surface temperatures, and a much different picture on the surface than what's going on down in the ocean. It's hard to believe how much the upper ocean and the lower ocean differ from each other. Let's get ourselves organized. Chile, Peru, Central America, Hawaii there, the equator at 0, the Galapagos right there. Warm water off of Ecuador. Ecuador's right there, making it out to a point almost south of California. Now this is the new one. Well, these are all kind of overlapping, so it's really there and somewhere out in here. The two cold pulse sort of gurgling to the surface, but not quite making it. And then residual colder water on out from there. Trades blowing from the east, high pressure, south and north, driving stronger than normal trades and upwelling and drawing cold water to the surface. And then the general whole La Nina signature, just plainly obvious. Much cold water off of Peru, Chile, but there is this warm water here, the residuals of a Kelvin wave. I think a lot of that's going to get eroded out as the new cold event eventually starts erupting in this area. Let's keep going. Sea surface temperature trend for the past 7 days. So pretty much a neutral trend from Ecuador out to a point south of California. But here is that at about 125 and 140 west, two cold upwelling events happening here, or two cold pockets, if you will. But we suspect that is directly related to what's going on subsurface. The rest, everything else, looking pretty neutral. And then just backing off, the big view again, a little bit of warming off of Ecuador. The cold event from filling the Nino 3.4 region, the area 120 west out to 170 west, 5 degrees north and south of the equator. This is the area that NOAA uses for monitoring El Nino or La Nina. Clearly, this whole area filled with colder than normal temperatures, a typical La Nina type signal. If temperatures were all warm out here, then we'd be in El Nino, but we're nowhere close to that. Sea surface temperature trend in the Nino 1.2 area. This is the area right there by Ecuador and the Galapagos. Temperatures today, minus 1.176 degrees below normal. But the trend is slightly up, but only for a little while. We think that's going to be falling as the cold water event starts making its way east. The official El Nino monitoring region, the Nino 3.4 region, certainly falling directly, minus 0.823, 823 thousandths of a degree below normal. The La Nina threshold is a half degree below normal, so we popped above that in the early part of June and held on till about almost the end of July, but now with that upwelling event, it's driving temperatures back down as a push back into La Nina. So we don't have any obvious support for Kelvin wave development in the next month or two. We have a cold upwelling event happening subsurface in the central Pacific. We have cold water starting to materialize on the surface in the central Pacific. What does the atmosphere think is going on? Is it reacting to that cold water? Cold water at the surface suppresses evaporation, and without evaporation, you tend to, when you have cold surface waters, you tend to get high pressure build on top of that, which is the hallmark, of course, of La Nina. So let's take a look at pressure differential between Darwin, Australia, and Tahiti. This is called the Southern Oscillation Index. Difference in pressure between Darwin, which is in the Indian Ocean, Tahiti in the central Pacific. When the index, right here, here's the index, when it's positive, that suggests pressure is higher in Tahiti in the Pacific and lower in the Indian Ocean. Today we're at 13.23. You can see we were a little bit negative for a couple of days, and we were doing pretty well there as we were in the end of July, but the value seems to be coming up a bit. No big surprise. 30-day average takes the noise out of this, 10.01, and it's a little lower than it was, but we were at 12 or 13. We dropped to about 6. This is probably the active phase of the MJO here in like late July, and now we're starting to head back up. This is the active-inactive phase of the MJO indicator. The 90-day average is your El Nino La Nina indicator. The value today at 13.00, and it is maybe a little lower than what it's been for the past month, but we expect to start seeing this going up as well. Here's a graph of the SOI over the past 2 years. You can see it was down when you're in negative territory. That would be weekly El Nino-ish here in January 2020. And then these upward spikes are the inactive phase of the MJO. You can see the trend has been steadily upward till at least through July. We had a pretty good active phase of the MJO, and now we're creeping up. And with that cold upwelling event, we think we will go up again. I don't think we're going to go as high as we went here, but we're going to go up a little bit more before hopefully we start heading down for good. And finally, the forecast for the Nino 3.4 region, the official El Nino monitoring region, sea surface temperature forecast. All right, so the solid line is what has happened so far. Again, the half-degree mark is the La Nina threshold. We've been in La Nina, October 2021 this starts. We're down here 1 degree below normal, clearly in La Nina territory. This is the raw data suggesting temperatures falling into about November, which would suggest a 1-pulse cold upwelling event that's underway now, falling to about 1¼ degrees below normal as we get into November. And then after that, you can see a steady upward trend, not only out of La Nina by January, but approaching El Nino, minimal threshold El Nino temperatures as we get into April and May. But this is raw data. It is known to not be correct. It is this PDF corrected version that is closer to reality. It shows temperatures about as low as they're going to go right now, dipping again as we get into November, and then steadily making that upward climb above La Nina threshold in mid-January, and not approaching El Nino territory, but just neutral, biased, warm as we get into April. Of course, by April, you're at the end of winter, you're into spring, but at least it's a step in the right direction. The sea surface temperature projections. Okay, so what we just looked at goes out about 6 months. Here's where we are more or less today. Cold water in control, sort of neutral temperatures out here by Ecuador. But then as we get into November, you see the extent of the cool temperatures fading, the upwelling event ending. And by the time we're into December, cool waters. Now the Nino 3.4 region is this area right in here. See a little bit of cool water there, but all this area off of Ecuador, all much warmer than what it is now, suggesting by December, that's mid-December, that we could be actually almost in normal territory ocean-wise. The expectation is the atmosphere above the ocean will probably respond pretty quickly. It's already probably sensing that the temperatures are getting warmer. So by the time we get into January, February, we might be able to eke out some semblance of a normal winter. And then by January, the cold temperatures are all but gone. We're back in neutral territory and we're in business. So for right now, a small gale is developing south of New Zealand. A little bit of swell result from that. Nothing too big. And then the models were teasing of a much stronger gale in the central South Pacific. But you saw the latest run of the model that just posted has downgraded that to just rideable surf kind of thing, but nothing too over the top. So potentially 2 swells forecast. But otherwise, not a whole lot going on. The North Pacific trying to wake up a little bit, but we don't believe it. We're not even getting it. We're not even going to get our hopes up by doing anything more than suggesting low pressure developing in the Gulf of Alaska. All right, and beyond that then, well, same old story. We're watching paint dry, but the paint is drying in the direction that we want it to dry, theoretically, assuming one last pulse of cold water that's happening right now. That should wrap up as we get into late October and November, and then the transition to ENSO neutral begins, and potentially we'll eke out a normal winter surf-wise, and maybe decent rainfall into California as we get deeper into the winter, say late February, March, and April, something like that. All right, so that's the video for this week. If you enjoyed the video, of course, give us a thumbs up. If you haven't subscribed, please subscribe. Comments, questions, I know a lot of technical detail here. Just give us a comment. We'll try to respond and try to explain whatever it is you don't understand. Remember, if you're thinking it, 10 other people are as well, so they will be grateful for you stepping forward to ask the question they're too scared to. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.